I actually do. It's gonna be late. It's gonna be late, actually. Execute that.
Johnny, I thought you were on our team.
Jackson's?
Yeah. Did you guys win?
I didn't get recruited.
No thanks to me in Bennett. But
Oh, yeah. That's
Y'all won though, right?
we won.
Jackson and Lucas, like, sorry.
Yes, exactly. Well, I wish I had my own team because I was not actually play, but
I was on Lincoln Wade and their team, but they played some, not played some people, but I was sat a little bit. Especially my brother's team. And we got the dub.
I was like, Johnny's the tallest one there.
I know.
That was funny. Did y'all win?
Yes, we won.
Wait, what is? Wait, on Academy. Right? Actually, no, because I hope maybe not. Oh wait, was that this one? Yeah, that was this one. Oh, is that okay? Wait, do I turn it into the basket? Or just basket. Did it have like without you? What was the test? Oh, easy. Yeah, I got one. Wait, what was that? What did you get on it? Like an old one from Ashland. Oh, okay. I got a 44. Out of what? No, I was on the second. Okay. Yeah.
Wait, are you a mountain?
No, there's not. Oh, yeah. I got one wrong. I got two wrong.
What's the amplitude circles and like the test of the
I'm not reading that.
Oh yeah, you have that
Do you
too.
think that's even the right?
Do you think I need to finish that?
Yeah, we did it in
That was when you were gone like a lot.
like, it was like really
That
quick.
wasn't that long.
It was like a week ago.
Why is it so freezing? You're cold. Wait. Okay, well like the one air vent in here. The two air vents in here are like turn in number 24. I'm not ready for this today.
Look at me go.
What?
I didn't know I did this. I am asking for one of those handouts we did together last class, so if somebody follows along with this, it should be 3 points, but I do need that in the basket.
Yeah, we did do it.
We didn't do
Okay, if you you didn't look under bill work, you need to look under that to see what needs to be turned in. I am taking up one quick assignment. Gabby, get you over here. All right. As the last couple of those papers come in, what we're going to look at today is we're going to focus on chain rule for most of the class. The first handout we're going to look at has a couple of, it's only got 4 questions on it, but 4 questions that were heavily missed on the Khan Academy assignment last year. I just assume that the ones that they struggled with are likely to be the same as the ones you guys struggled with. So I want to go over those. Then we're going to do circuit on chain rule, and that will be the bulk of our class time. And I will follow behind and help you out with a bunch of that as well. And then the other handout you picked up is the test review. And the test review does not have to be fully completed by Thursday. But like in Unit 1, I'm going to say that you should aim for at least half of it. More if you feel like you've been struggling. Because on Thursday, you'll need to finish, figure out what questions you need help with, what topics you need reviewed on, and have that done in time that I can help you. Next class will be our review class. Okay, so 26, common chain rule missed questions from, this was actually not y'all, but last year's group. So let's just talk about these real quick, just kind of as they work as a refresher for what we did last class anyway. So, to emphasize that people should get way more of these right, you can see last year only 1 out of 12 people got this question correct. So it was trying to take the derivative of the natural log of x cubed. So we've got something being cubed. So bring the power down, lower the power by 1, and then the chain rule part is that inside stuff, the stuff under the cube, you have to come back and multiply by his derivative. So that would give us choice A. Now, I probably said this last class, but sometimes I just forget. I'd rather repeat myself than to not tell you something important. But generally, when you guys are asked to do a derivative and it's a chain rule question, where chain rule is one step of the question, you should notice that one of the answers, one of the distractor answers, should always be the correct answer without the chain rule step. So notice D is tempting to pick if you forget to come back and multiply by the derivative of natural log of x. So you're going to see that throughout these. We're going to do question 2 last because it was the hardest of the 4. Right now? You need to go to first floor, phase 4 office.
Me?
Yeah. Okay, so slide over to question 3. If you want to take the derivative of natural log of something, just like the derivative of natural log of x is 1 over x, if it's natural log of other stuff, it's still going to be 1 over other stuff. But make sure that you remember to come back and multiply by the derivative of the other stuff, because that is the chain rule step. Derivative of square root of x is 1 over 2 square root of x. Okay, number 4 is probably the easiest one on here. The derivative of cosine something is going to be sine something. So again, last class we talked about, don't worry about how complicated the something is. Just remember to come back and multiply by the derivative of the something. Except derivative of cosine is negative sine. So notice if you forgot to do the chain rule step, the multiplying by 5, Notice how your answer would have been there, A. That should always be the case. One of the wrong answers would be the correct answer if it had the chain rule applied to it. Okay, and then this one just has a little bit of simplifying to it. So e to the x to the 1/2 is the same thing as e to the half of an x. So if I start thinking about derivative, the derivative of e to something is going to be e to something, just like e to the x is e to the x. Just make sure that you come back and you multiply by the derivative of the inside. Now, x over 2, remember x over 2 is the same thing as 1/2 times x. So his derivative is 1/2. Oh, I'm sorry, I lied. E to something is e to something, come back, multiply by the derivative of the inside. Okay, never mind, that looks okay. Which is choice B. It's like e to the x with square root times 1/2. Timesing by 1/2 is putting a 2 in the denominator. So I don't know, maybe you guys don't think these questions are tough. Maybe you saw these on your Khan Academy and you didn't struggle with them. Obviously that's best case scenario, but I feel like all of these questions are good, fair game questions for the test. Obviously you're going to feel more comfortable with chain rule after we practice the circuit today, but is there any of these four you want me to be more specific about or detailed questions on? Okay, then let's quickly slide over to the circuit. Again, ideally I would like you to finish up the circuit in time that you can get a chunk of the test review done too, so you don't have too much homework. But again, part of this just depends on how quickly you catch on and how well you learned the stuff we've been talking about. So what I'm going to do is I'm going to set a 4-minute timer, and in the 4 minutes I will take questions from number 1 or number 2. And then I will try to be right behind you today with a little more hustle than normal. Bless you. Okay, it's been 4 minutes, so give me just a second and I will share my first 2 answers with you, and then I'll work out one or both of those if you need me to. Okay, my first 2 answers were number 1, I ended up with the derivative being 10 times an x squared plus 7 to the 4th. And then let me share answer 2. And then if you got both of those, keep going. And if you don't, you need to ask for help. That's number 2. Okay, number 2, I got 5x over the square root of x squared plus 7. Okay, does anybody need to see number 1 worked out? Everybody's okay with number 1? Does anybody need to see number 2 worked out? Number 2 looks like it had some simplifying, maybe common denominator or something at the end. Number 2? Okay. Okay, so from our constant multiple rule, if this is just 5 times something, the derivative is going to be 5 times whatever the derivative of this is. So think of this as exponent of a half, and the first step is going to just be regular chain rule. I'm sorry, not chain rule, power rule. Bring the power down, lower the power by 1. But since there was an inside to that question that does not have a derivative of 1, chain rule says you need to come back and multiply by that derivative. So times 2x. So in all of this, I see I have a times 2 and a divided by 2, so I just canceled those out. I've got a 5 times a 1 times an x that makes up my numerator. And then since this has a negative exponent, I know that they're going to move that to the denominator. And they probably won't leave it as 1/2. They'll probably change it to the square root. That's how I came up with that. Okay, let me give you another 4 minutes, and then I will take questions from 1, 3, or 4. You don't have to let him in if you don't want to. You got lucky.
Excuse me?
Nothing.
How do I get lucky?
There's only one person willing to open the door for you.
Oh, yeah, that's John. That's my boy right there.
You should have about 4 questions in now.
I'm about 3. I'm getting there.
Good.
Mr. Nelson?
Yep.
Are we allowed to ask questions?
What are you working on?
None of us know how to do number 5.
Okay, so you rewrote it well. Brought the power down, lowered the power by 1. Okay, so now your insight was this. What's the derivative of sine something?
Cosine.
Okay, so right here, you need cosine of that something,
Okay.
cosine of x squared.
Okay.
And then there's a new inside, so then you have to do chain rule a second time.
Okay, thank you.
Yeah, I don't mind if you ask questions, but I don't want to get too far ahead up here.
Could you do problem?
Yeah, I will, when we get there. Yeah, if you guys really get stuck on one, just try a different question while you wait. I just don't want to rush. If I do question 6 before, well, Johnny's on question like 2 because he went to the bathroom, but
I'm just taking my time.
that's what I'm worried about.
Derivative of the sine is negative cosine.
No. Not correct. Okay, it's been 4 minutes, so here's my answers to 3 and 4. I will take questions from number 3 or number 4. Number 3 had an answer of 2 times x times a cosine of x squared plus 7. And number 4, I got 3 times x times the square root of x squared plus 7. So, does anybody need to see number 3 or number 4 worked out? Okay. 4 more minutes, and then I'll take questions from the first 6.
Wait, let me finish.
You know what that is?
Wait.
Okay, you take it. Did you figure it out? Not quite, but I think one.
Wait, stop. Wait, I see this right here. No, but this guy. Oh, yeah, that's one. Yeah.
Okay, it's time to check 5 and 6 and see if you need to see either of these worked out. Here's what I got for 5. Let me share both answers. I suspect some of you are going to ask about this one since some people were trying to a minute ago. But if you got that as 5, go ahead and keep going. What?
Can I ask how you got 4? walk me through that?
No, not yet. I'm gonna share both answers first.
Yes, sir.
Okay, there's number 6. Okay, so number 5, here's number 5 worked out. And to be fair, the very, very last step of this question you may not have thought of because it hasn't come up yet. But one thing I would suggest, what really, really scares me about trig functions is this is sine squared. So that's the same thing as the sine of x squared all being squared. So you probably should write it like this first. They mean the same thing, but you guys do a much better job if you write it like that. So your first derivative step should have been power rule. Bring down the exponent and then lower the power by 1, so it becomes a 1. But there was an inside to that. The inside was sine of x squared. And what's the derivative of sine something? Okay, so cosine something. Now the part that you may not have thought of, because again I just don't think that this come up, isn't there an inside to that part as well? So sometimes you have to do the chain rule more than once. If there's an inside to the inside to the inside to the inside, you're going to do chain rule 4 times. That's extremely rare. It's not that uncommon to have to do it twice though. So the first time, sine of x squared was the inside, so I took its derivative. The second time, x squared was the inside, so I had to take its derivative too. So in the end, the 2 times the 2x is where the 4x came from. And then we have the sine of x squared and a cosine of x squared. So if you didn't think to do the second chain rule, that's fine the first time. I've not told you that chain rule can happen more than once. But now that you see it, you should be aware of that. Okay, does that clear up everything about number 5? Okay, anybody need to see number 6 worked out? Okay. All right, so if you don't need 6, go ahead, keep on going wherever you left off. Oh, 6 is definitely one of the harder ones. I think 6 and maybe 7 were 2 of the longer questions. Then they get shorter again. Okay, so first off, this is 2 times some stuff. I'm just going to put the 2 out front. Remember the constants you can just deal with later. Pull them out front and deal with them later. That makes it one less thing to keep up with. But one thing that makes this question longer and more difficult is that now we're trying to find the derivative of x times the square root of x squared plus 7. So there's only one way to do that, and that is product rule. Something in terms of x times something in terms of x. If you can't rewrite this with algebra or exponent rules or fraction rules or anything like that, your only option is to do the product rule. Take the derivative of x with this left alone plus x left alone times the derivative of this. So you'd have to bring the 1/2 down. You would lower the power by 1. And because there's an inside here that does not have a derivative of 1, you have to multiply by the derivative of the inside. All of that's the derivative. Now somebody today, second period, asked a good question. How do you know how much you need to simplify? Or when, like on the test, how would I know how much I need to simplify? And again, it just depends on the question type. If it was a free response question and it said find the derivative, if I was you, I would stop there. That's the derivative. It's ugly, but it is the derivative. If it was just a short answer, fill in the blank type question, I would again stop. If I just asked for derivative, you gave me the derivative. But a lot of what we do is multiple choice on our test because that's how your AP exam is. And your AP exam is not going to have multiple choice answers that unsimplified. It's going to do some of the work here. So of course, for us, we have something to aim for because we're trying to get it to match up to one of these answers. So we could do something like times 2 divided by 2 are going to cancel. I guess I can go ahead and distribute this 2 back now that I've done the derivative. So distribute the 2 back. This would be 2x. And then if I move this to the denominator to make it have a positive exponent, it looks like that. And then when this came up second period, I started looking at my answer choices because I do not want to have to do common denominator unless I have to, but none of the answers look like this. So I realized, let's get a common denominator. I have to go down here to get more space. So the common denominator is going to be the square root of x squared plus 7. This already has that denominator. I'm going to have to multiply this one, top and bottom, by that, so that it's like you're multiplying by 1. And then we're left with 2 times the square root of x plus 7 times the square root of x plus 7. What is the square root of x plus 7 times the square root of x plus 7? X plus 7? X squared plus 7, okay. And then now that they have a common denominator, we can squish them into one big fraction. These two x's are I'm missing something here. Right here. I had an x times an x. This should have been an x squared. Sorry. So these two x squareds plus these two x squareds gives you 4x squareds, and the 2 times the 7 gives you the 14. And that's how they have question 7 looking, the start of question 7. So again, chain rule is not a new type of differentiation. It's one additional step. So when you do the power rule, sometimes you do chain rule after that. That's what you did in the first 5 questions. In question 6, we had to do product rule, and one part of the product rule needed chain rule. So there's no such thing as derivative that's just chain rule. It's chain rule after power rule, or chain rule after product rule, or chain rule after quotient rule. Chain rule is just an additional step, not a new process. But this is definitely one of the harder ones. But is there anything detailed about number 6 you need to ask? Okay. Then go ahead, keep going, please. So let's try to be ready for the next 2 in another 4 minutes, please. For what it's worth, I think second period today, question 6 and 7 seem to be the ones that gave the most issues. And they're 2 of the longer questions. Well, I don't know. 7 just depends. And if you're still having to look up derivatives from your derivative of trig functions from your notes, please make sure you're putting in a good effort to memorize them. Okay, so for 7, I ended up with negative cosecant x times cosecant squared x plus cotangent squared x. And then the second one I'll give you opportunity to ask about is the one after that, number 8. Number 8, I got 2 times an x times the secant of x squared plus 7 times a tangent of x squared plus 7. Okay, so first up, any takers for number 7? Anybody needs to get number 7 worked out? Okay, good. Nobody wants to see number 7. Okay, number 7. Now, I will just be frank with you here. When I did number 7, second period this morning, I started off with quotient rule because I see something divided by something. And I did it that way, and I did it correctly, but I could not figure out how to get my answer to manipulate and to look like this. So it's not that I did anything wrong, but sometimes two statements can be equivalent but look so drastically different that sometimes you might want to just start over and try something different. So the second time, I split this fraction up. I put cosine over a sine times a 1 over a sine. You guys okay with these being the same thing? Okay. And what do we call cosine divided by sine? Okay. And 1 over sine is cosecant. So really, this question doesn't even have chain rule. You could just straight up do, if you thought to rewrite it, split it into two fractions and use your trig identities. There's no chain rule, you just had to do product rule. So to get the answer to this, take, now again, this is what I was saying a second ago. If you've not memorized the 6 trig derivatives yet, it's fine if you're using your notes, but try to lean on them less and less so that you're not trying to memorize them the night before the test. But the derivative of cotangent is negative cosecant squared times another cosecant left alone, plus, and then the derivative of cosecant is negative cosecant cotangent times the other cotangent left alone. And then if you look at our two big terms here, this term and this term, they have some stuff in common, so you can factor out a GCF. They both have a negative. They both have a cosecant x. And if I'm factoring that out, this would leave behind a cosecant squared minus a cotangent squared. Actually, when I factor out that negative, that switches this to a plus. So once again, I'm not saying that's the only way to get to that, but after I tried quotient rule, because that's what I thought it would be, and my answer was correct, but far from looking like that, I started over and just tried a different approach. So again, I just rewrote it, and the way I rewrote it, I didn't even need chain rule at all. Okay, so other than maybe memorizing the trig derivatives, is there any other part of 7 that you still need help with? Okay, then here's your offer for number 8. Anybody for number 8? Yes? Okay. Sorry, give me just 1 second. Okay, so number 8, looking at the answer here, it looks like this might be a pretty scary looking question. But honestly, it's just 2 things. Memorize trig derivative, don't forget chain rule. The derivative of secant something is what?
Secant, tangent.
Okay, so secant of the something times the tangent of the something. That's the trig derivative that you just memorized so that you can do it that quickly. And then don't forget chain rule. There was an inside piece here, x squared plus 7. Chain rule says you have to come back and multiply by that derivative. So rearrange them, and then that's where that answer came from. Okay, everybody that was going to ask about 8, that's good enough? Okay, keep going. I was wrong. 9 was probably the hardest one for us, second period, so it's a much longer question. I'll give you more than 4 minutes on this group. They do get quite a bit shorter and not as complicated after question 9. Or at least I think so. Guess everyone's different.
was looking for information on how. No, I didn't see the Yeah, it's
Okay, I gave you 6 minutes this time, but again, as I said, number 9 is probably the longest question, which means it's probably also the hardest question. So it's the one that ended up being 2/3 x cosine x minus x squared sine x minus 7 sine x's all over x squared plus 7 to the 2/3. And I know at least one person needs to see that, so I'll work that one in just a second. But let me also share answer 10 with you. Question 10 ends up being a lot more efficient, or not nearly as long of a question, because they give you a table of values and you just have to figure out what to pull from where. So number 10 should come out to be -4. Okay, so let me work through question 9, and then if anyone needs question 10, I'll do that one too. Alright, first thing about 9 is you need to realize that your only option here is to do product rule, because you've got something in terms of x times something in terms of x. And so we can take the derivative of the first term, bring the power down, lower the power by 1. I'm not going to worry about simplifying yet. But there was an inside to that. The inside was x squared plus 7. So chain rule says you need to multiply by that derivative. So times 2x. So derivative of the first part times the second part left alone, plus, now I'll do the derivative of the second part, which would be negative sine x, times the first part left alone. And technically, this is the derivative. So I did the product rule, and one time I had to do the chain rule within that. Okay, now as far as trying to make it look like their final answer, I don't know. All I could do was start simplifying. I knew this negative exponent. I'll pull this stuff up here. This is a 2x a cosine x. This is a 3, and then when I move this stuff to the denominator, it makes the exponent positive. So then I looked at my answer choices, hoped that one of them looked like this, and none of them did. So then the next thing I figured out is, well, they must have gotten a common denominator then. So this guy currently has a denominator of 1, so I'd like to multiply it by this stuff. And you can't multiply the bottom without multiplying the top. Otherwise, you're changing the size of it. And then, of course, the purpose of that is to get a common denominator so that we can shove it together as one big fraction. And I've got a 2x cosine x minus a sine x. Now, oh, and a 3. Let me put that 3 out front. This 3 sine x. Now, what about this part? What is x squared plus 7 to the 1/3 times x squared plus 7 to the 2/3? Good. So to the 3/3, right? These have the same base. Add the exponents. 3/3 is just to the first. And okay, now we're almost there. So the other thing they did was they distributed. And again, I had no idea, there's nothing about this question that says you have to. They just chose to. So this isn't sine of all of this stuff. It's sine of x times this stuff. So we can actually distribute here. 3 sine x times x squared. And negative 3 sine x times 7 would be minus 21 sine x. So they chose to distribute that. Again, no idea why. It's not considered more simplified, but that's what they did. And then the last step, I have no idea why they would want to do this, but I could figure it out from their answer choices. This was a 1, so they divided this by 3, which is okay to do as long as you divide every term by 3. So this is where the 2/3 comes from. And the minus 7 comes from. That dividing everything by 3. Again, I wouldn't normally do that, but I only did that because I knew I had to keep trying something to get to their answer. Okay, so a lot going on there. Is there any of those steps you'd like to ask something specific about? By far the most important part here is knowing the product rule, being able to apply the product rule to get started, and understanding why I'm multiplying by 2x here. Understanding when you need chain rule and when you don't need chain rule. Okay, what about question 10 then? Does anybody need to see 10 worked out to get negative 4? Sure. Okay, so these table type questions, again, to me it's exactly the same thing. Honestly, it's a little bit easier because they're doing some of the work for you. But when I saw you guys last time, I put a few tips on the board for your Khan Academies, and one of them was getting you to write down this formula for chain rule. It's the same chain rule formula, but I think it's nice to think of it this way for tables. So if I want to take the derivative of this guy, the derivative is, I've got a function plugged into another function. That's how I know I should be concerned about chain rule. Chain rule says take the derivative of the outer function with the inner function plugged in times the derivative of the inner function. So this was the hint I left up on the board at the end of class last time. And I just think that this is easier to work with than trying to do all that in your head and think about which one of these you're trying to do. So if you want to know h prime of 2, it's this stuff, but instead of x's, there's 2's. And now you just need to get this information out of the graph, or out of the table. G of 2 is -1. G prime of 2 is 3. F prime of 1 is -4/3. And -4/3 times 3 gives you -4. So, I'm not saying you have to memorize this as a formula, but it does seem to help some students. It's the same thing we've been doing with the functions the first 9 questions. Derivative of the outer with the inner plugged in times the derivative of the inner. But force yourself to write out the derivative. Force yourself to change the x's to a 2, and then it's a lot easier to see where those numbers are supposed to come from. Okay, anything specific about question 10? Okay, I'm going to give you just 4 minutes to try the next 2. Again, they should be a little bit faster after question 9.
Because the input is positive, it's not going to be I did the equation very quickly. I did the equation. It's on the same line. Yeah. Have you done I'm done for home. There's no issue after that. Oh. Oh, they want a good trees.
Okay, my answer to 11 was 21. And my answer to 12 was -2. Okay, anybody for question 11? Anybody need to see number 11 worked out? Okay. So the first part should actually be pretty easy. Easy that like it should be like one of the first couple questions. Just do the derivative first. So do power rule, bring the power down, lower the power by 1. So this is the derivative of the outer with the inner plugged in times the derivative of the inner. Now, how in the world did this that has t's in it become a number? Right, so this is the first question where they didn't want the derivative, they want the derivative at a specific value. So now, plug in 1, so you get 7 times 1 minus 2, which would be -1. -1 to the 6th power is +1, times 3 times 1 squared. So you end up with 7 times 1 times 3, which is 21. So power rule, chain rule, evaluate at t equals 1. Now again, that's not necessarily easy, but compared to some of them, compared to like that question 9 and how many steps it had, it's considerably easier. They won't all be terrible, but we just have to practice. Okay, and then 12, I got an answer of -2. Anybody need to see number 12 worked out? Yes? Okay. So if you need number 12, stay with me here. Okay, so I've got G, I've got H, I'm supposed to find, here's F, and I'm supposed to find the derivative of F at 1. So first thing is I'm going to try to think about the derivative of F. I'll worry about the plugging in -1 at the end. But I don't know. We could go about this a couple different ways. We could either do this algebra. We could just plug G into H and see what it looks like. Or we could try to do the formula part, but I think it's going to be easier if we just plug this in. H of G means you're plugging G into H. So before I do any derivatives, let's just plug in G into H, and it would look like the square root of 3x squared minus 6x. Everybody okay with that? Okay, now I'll worry about derivative. So this is like an exponent of 1/2. So bring the power down, lower the power by 1, and don't forget to take the derivative of the inside, which would be 6x minus 6. Now, if you want to simplify a lot, more power to you. But the fact that I'm just going to plug in a -1, why take a couple minutes to try to make this look nice and neat just to plug in a -1 when you can plug in a -1 right now? If I plug in a -1, I get, this would be 3 plus 6 to the -1/2 times -6 minus 6, which would be -12. Okay, 3 plus 6 is 9. The square root of 9 would be 3, but this is negative, so that makes it like 1/3. And then -12 divided by 6 would end up giving you -2. So I don't know. You may not take the same ordered that I did at the end, but you're just plugging in -1 everywhere there's an x and simplifying. Or simplifying as in doing the arithmetic. But I guess my tip for you there, if you just had trouble getting started, if you're trying to find the derivative of f, and this is f, just plug all of g into h, and then you can make f look like this. I mean, it's kind of similar to the first few. Okay, I'll leave that up and give you a few more minutes. Push. Okay, my answers for 13, 14. 13, I got -2/9. Most of that one, it's just knowing the derivative of the trig function. Well, and unit circle. Got to use unit circle a few times there. And 14. Question 14 was negative 3x secant squared of 3x squared all over the square root of tangent of 3x squared cubed. So I think 13's definitely the easier of the two, but does anybody need to see number 13 worked out? Yes? Okay, stick with me here if you needed help with 13. So the first part of 13 that you just have to memorize is the derivative of cosecant something. It's going to be negative cosecant something, cotangent something. Now this one has chain rule because the derivative of x over 3, you might want to change this to 1/3 x. These two mean the same thing. For whatever reason, sometimes students have trouble seeing the derivative of this. The derivative of this is 1/3. So the chain rule was multiplying by 1/3. And then the second part of the question is now go and plug in pi into the derivative. And again, sometimes you can simplify this, and if you want to simplify it and then plug in the number, you can. I would just recommend plugging in the number as soon as you see the derivative. Okay, so to answer question 13, we're going to have to think about the unit circle. At pi over 3, cosecant's the reciprocal of sine, and at pi over 3, sine is square root of 3 over 2. At square root of 3, cotangent is square root of 3 over 3. And so the times square root of 3 divided by square root of 3 cancels. Along the numerators, we've got -2, and along the denominators, we've got a 9. Now again, I'm just doing these unit circle in my head. Obviously, if y'all need to go over to the side and make a unit circle and think carefully about what sine is, and I mean, be as careful as you need to there, but that's what the process would be. Okay, was anybody else going to ask about 13s? Need more than that? Okay, then 14. Okay, I'm assuming at least one person probably needs to see this one. Yes? Okay. Let me record it in case some people are not this far along on the assignment yet. Okay, so personally, before I even started worrying about derivative, I guess you could do quotient rule here if you wanted to. You've got something divided by something. but it's probably a smarter idea to just rewrite this. So if I bring all of this up, instead of this being to the positive 1/2, if I move it to the numerator, now it's to the negative 1/2. If you move it to the other side of the fraction, the exponent changes signs. Just we usually go from negative to positive, but you can go from positive to negative. So now the first step of the derivative is undoing this power rule. Bring the negative 1/2 down. Lower the power by 1. Don't worry about how messy the inside is, it just stays messy. Times the derivative of the inside. So chain rule says multiply by the derivative of tangent at 3x squared. And the derivative of tangent something is going to be secant squared of that something. But that something happened to not have a derivative of 1 either. It had a derivative of 6x. So here's a second question where we had to do the chain rule twice. The first time, this stuff underlined in red was the inside, so I had to take its derivative. And within taking the derivative of it, there was an inside which I underlined in purple. So if you've got to do chain rule 20 times, if there's 20 insides, then you've got to do chain rule 20 times. You will never have to do 20 times for us, but okay, and then I need to try to simplify this and make it look the same as everything else. So I've got a times 6 divided by 2, so I could change that to a 3. In my numerator here, I've got a negative 1, a 3, and a secant squared of 3x squared. And then I'm going to move all of this to the denominator and make it have a positive exponent. And the only other thing that they did was, well, one, they didn't lose their x. I almost lost my x. They just made the denominator look slightly different. Instead of saying this is all to the 3/2, they said it's all to the 1/3. And then did square root. Square root compensates for the to the 1/2. So had to rewrite it before you undid power rule, or you could have just started with quotient rule. Had to do chain rule twice because there was 2 inner parts. And if you kept up with all of that, then you probably finished it just fine. Okay, is there anything specific about 14 while it's still there? Okay. had not worked out question 15 yet, so there's my 15. Answer circled. So I said the derivative of cosine something is negative sine something multiplied by 3 for chain rule. Rewrote it, plugged in pi over 4. And then I had to do unit circle once before I got the final answer. Is there any of those steps you're not okay with? Okay, so even if you did not get a chance to work ahead, you should have just a few left. And of course, the less that you have, the least number that you have a little bit of a hint because you've got less answers to try to compare it up to. So I need you guys to finish that up, please. And then again on the test review, I'm asking that you do at least half of it, but it can be any half. I'm fine with you even going through, picking through ones that you feel comfortable with, doing those, make sure that you're comfortable with those. Because again, on Thursday, I need you to have time to finish, identify what it is you need help with, and have time to get those answered. And if you don't work half of it between now and Thursday, then you're not going to finish it in class on Thursday. You're not going to know what you need help with until you're out of class on Thursday, and then you are going to be on your own to try to figure it out. So again, it can be whatever you consider to be the easiest half, but please do that. And if you really feel like you're struggling, you should probably do more than half. Honestly, the best thing you could do is to try to do the whole thing, pretend like the test is next class, come in, get extra help, and that's like a little bit extra time. But all that being said, we got about 5 minutes, so if you'd like to try today's puzzle, I will leave it up on the board for you. If you have any questions about where you need to be or what your homework is, please come and ask before the bell.
This one was because I didn't get to see the rest of it.
Okay, well let's add those together. 3 pi over 4 plus pi. That's like 3 pi over 4 plus 4 pi over 4, which is 7 pi over 4. Okay, what's the sign of 7 pi over 4?
Wait, you're done the one?
Is it root
You got like 2 minutes to go over that.
So then you can replace sine of 7 pi over 4 with negative square root 2 over 2. And nothing is negative 3 times that. Yep. Johnny, you can't go with her.
I was absent when we had these assignments.
Okay, you got your name on all of them, or you just staple them, but put them in the.
I'll save that.
Yep.
Do we have to come ourselves now?
No,
And
I might ask for it next class, but
I don't know. She said we could help me 16. I messed up so much.
okay, you rewrote it. That's a good idea. Bring the power down, lower the power by 1. You did the chain rule. I don't know if you thought about it or not.
Oh, I was
You need
just
to be-
taking the derivative.
Well, part
well,
of taking
you
the,
have to.
yeah.
Yeah.
You need times a 2t minus 2 with your derivative there. That's probably what happened.
So I was also absent for the day that we did the product and quotient circuit.
Okay.
And so, but I know that like technically by now, since I came to class Friday, it'd be like today would be the day that I need to turn it in.
Okay.
Would that mean that I'd get like half credit for it, and you give it back to me, and I can finish the rest.
If it's late, the best you can get is half credit.
But I thought that today would be the day that it would be due, since I missed.
I don't know, I'd have to
The
look at
day.
the days that you missed to be
Okay.
sure. What that would be is you would have to turn in, if you turned it in incomplete by your due date, you would get half credit. Then you can finish it to get the other half.
Right. Right. And I think that today is that day.
Okay.
So
Yeah,
I'll
so
just
if you
throw it
give
in
me
the
some
basket.
of it, yes,
Okay.
then I can give you half credit and you can finish it before the test to get the other half. Okay. Has anybody got any ideas on how to do this?
Sorry, I don't understand.
A plus B plus C plus C plus
Except for,
Somebody yesterday came up with a really, if you just think about the far right part, there's a good hint you could get.
how to put it, right? Or 10 or something like that.
Hand?
10.
Why does A plus B have to be 10?
Because C is 0 and C is
Right, so along the right side, A plus B plus C, the only way that's going to equal C is if it's A plus B is 10, so that's like carrying the 1.
yeah. Then
So that gives you a hint.
C plus 1 is C.
Huh?
So then A plus B plus C plus 1 is 3. Right?
A plus, I can't do that.
That's what
A
I
plus
did.
B plus C plus 1.
I did A plus B plus C plus 1 equals.
Oh.
I'm gonna be on a mountain trip next class.
Okay, September. Oh. Okay, you know where to get your makeup work on the classroom site?
Yes.